An IEnumerable is able to iterate. That's how we get our for each loops in C#. But with an IAsync enumerable, it iterates over a task. And again, we always want to pass in a cancellation token to that task. And so by just decorating our cancellation token parameter with this enumerator cancellation attribute, .NET, every time this for each loop iterates, so let's say task.whenEach completes, we get our value, and then we loop back. When we do that iteration, .NET, the runtime, will actually check our token. So highly, highly recommend always using enumerator cancellation attribute for your cancellation token methods in IAsync enumerables, because now you never really have to worry about canceling the task yourself, or rather checking it. Because if we didn't do this, let's pretend like we didn't know about this yet. Well, what we would do here is say something like token.throw of cancellation requested. So this ensures that we still break out of the for loop when the caller of this method cancels the token. But we don't have to do this. Instead, we can just say enumerator cancellation, and then we never really have to check our token inside of our await for each loop. Okay, so I'm also getting yelled at down here because I'm not using the cancellation token here either. So let's see what this error says. Let's scroll a little bit so I can see it. Use cancellation token. And let's see if IntelliSense is smart enough. Boop. There we go. How cool is that? We didn't even have to know anything. It did it for us. So kind of similar to wait async. We saw wait async earlier, and we said this is a way you can bolt on a cancellation token to a task that maybe doesn't allow you to pass one in. Well, likewise here, whenEach, let's see, there we go. So whenEach doesn't allow us to pass in a cancellation token, but because it's an IAsync enumerable allows us to use this extension method with cancellation. So you can kind of think of with cancellation the same as you think of wait async, but one is for IAsync enumerable with cancellation, and the other is for task wait async. So same idea, but again, a little bit more going on under the hood because this token, again, is being passed into these .NET iterator here for us. So take advantage of all these, the enumerator cancellation attribute, the .with cancellation token, because this is a way we can actually pass in our tokens into the .NET runtime. In reality, it just saves us a lot of code. We don't have to check that cancellation token. All of that, it'll happen for us automatically. To review, this method here, and actually, I see a bug. Let's also make sure if story count, so we'll just say if story count is 0, break. And then here, we'll say story count minus. That'll work. So that way, we still use the story count variable. We don't get necessarily 2 billion if we don't want 2 billion examples. So, all right. So walking through this method, now that we've refactored it, we're using IAsync enumerable. We first start out by creating actually, we don't even need top story list anymore. Boop. All right. So we really start out by getting all the story IDs. So we call get top story IDs. This is just one API call to the Hacker News API. We use configure await false, so we don't return to the calling thread. We get a little performance improvement there. And then the next step is where we fire off all these tasks. We create a whole list of tasks, one for each top story ID, where we're calling the get story API. And now all of these are running in the background in parallel. And instead of waiting for all of them to finish before we start returning our results, we take advantage of task.whenEach to leverage IAsync enumerables with our cancellation token, of course, to yield return each story. And just to go over this a little deeper, let's break out the code like this. There we go. Yield return. This is a bit of an obscure concept in .NET, and you've maybe never seen this unless you've done some work with IEnumerables, some where you can also yield return. But yield return tells .NET to just return this value, but yield return says don't return from the method. Don't leave this method. So what happens here is we get our top story from top story task. We say yield return top story, and the yield return brings us back up to here, to this await for each loop, where, by the way, we can absolutely use configure await false for our await for each loops. So yield return, we hit this value, yield return, or rather hit this keyword, returning the value, and yield return immediately brings us up to here where that story gets added in. And then when we iterate this for each loop, .NET returns back here to decrement story count, and it'll continue running this await for each loop until either all the tasks finish or we hit our maximum story count. So again, yield return, a little bit different than just normal return because we don't actually leave the method. We just yield this value, top story, back to our calling await for each loop. And again, this is how we can show the values on the screen to the user as they're coming in, just like this. Helps the user feel like progress is being made and helps ensure the user doesn't just stare at a blank screen for 5 seconds, hating their life. So that's async enumerable. That's another refactor done. Now let's pause here before we move on to the next section where we'll talk about returning a task instead of awaiting it and value task.